Hello, I am Lorenzo Moore and I'm going to present this paper, Multi-Label Affordance Mapping from Egocentric Vision, accepted at the ICCB. Affordances are all the potential actions that the environment offers to the agent, which makes them a multi-label problem. Furthermore, the egocentric perception requires a close spatial semantic understanding, as we can see here in this picture, since the properties of the objects depend a lot on their spatial context. Though the interest of computer vision community in affordances is not new, previous works were limited by the amount of information that they were able to extract from the scene. For example, unsupervised methods, which learn by watching interactions, use single labels or lack pixel-wise precision. On the other hand, supervised methods are expensive, since they are very difficult and costly to label. Therefore, these are our following contributions. We present epic affordances, the first multi-label affordance segmentation dataset. We built an automatic pipeline in order to collect multi-label affordance masks by watching real-world interactions on the epic kitchen sequences. Also, we evaluate a state-of-the-art segmentation model in the multi-label segmentation problem, and we present, as we can see here in this picture, a metric 3 representation with activity-centric zones, which allows us to perform goal-directed navigation tasks. Here you can appreciate the pipeline that we built in order to extract multi-label affordance masks from a sequence of videos. It takes the best of the two worlds. On one hand, it learns by watching real human-object interactions, and on the other, it doesn't require any extra labeling, and it becomes easily scalable to other egocentric datasets. First, from all the videos available in a certain environment, we sample all the frames when an interaction occurs. As you can see here in this picture, we select the interaction point as the intersection between the hand and the active object bounding boxes. Then we apply call map in order to have a common 3D representation of all the interaction hotspots that occurred in that kitchen. This cross-temporal spatial representation is going to constitute our knowledge base. Finally, when we reproject from the 3D to a single image all the past interactions, we filter according to the current object distribution in order to select which were the available affordances. At the end, we obtain this detailed multi-label affordances mask. These are qualitative examples of the epic affordances datasets. As you can see here in this image, we were able to extract up to 8 different affordance masks from a single scene. Also, our masks are pixel-wise, and we present 2 different versions of the dataset. One of 20 different affordance classes, and the second one more challenging, up to 43 different classes. And furthermore, our approach is interaction grounded, which means that we have learned all the affordances by watching the videos of real interactions. In order to develop our perception model, we started by applying different heuristics to the classical multi-class problem. For example, as this figure illustrates, we select the top k winning classes of a multi-class problem. Then we transform the models into a multi-label problem, which requires to perform n different binary classification problems. Finally, we also implement the asymmetric loss in order to operate differently in positive and negative examples. We detail the results of the model applying multiple state-of-the-art models in the paper. Our approach allows a multi-label affordance mapping, which creates a 3D representation of the different affordances, which are also consistent along different viewpoints. As we can see here, the catboard is closable at different time steps, and also we obtain multi-label interaction hotspots at different levels. Finally, since we have a map, we can guide the agent to the places it visited in the past, performing a task-oriented navigation. For example, at this time step, at the end of the sequences, when the agent has ended of washing the dishes, he remembers where he dried them in the past. In this proof of concept, the agent is able of navigating to the activity-centric region from the point A to B, as this path shows. This could have multiple applications, like aiding visual impaired people. I hope that you enjoyed the poster and be inspired, and here you have the links in order to download the dataset.